So here's an alternative method now. This is an alternative method for solving quadratics. We've got a z squared equals a here. And I want to show you this because it does sometimes come up, okay, where they ask you to use algebra and not Demoivre's theorem to solve. It only comes up with quadratics, so don't be afraid, it's lots of fun. So example 2, solve z squared minus 5 minus 12i equals 0 using z is a plus bi, okay, forcing us to do it in Cartesian form, where a and b are reals. Okay, now we have z squared equals 5 plus 12i, and we have to find out what z would be. We're expecting 2 solutions for this. So, okay, we're substituting z is a plus bi, and therefore we've got a plus bi all squared equals 5 plus 12i. Therefore, let's multiply this little left-hand side out and see what we get. Okay, quadratic expansion, we get a squared plus 2abi plus b squared I squared, which is the same as minus b squared. Okay, alright, so therefore, by equating coefficients, we can say that the real part of this bit here, the a squared minus b squared, must be the same as this number here, which must be equal to 5. And we can also say that the 2ab, the imaginary part, must equal 12. We've got two simultaneous equations, and we're going to go ahead and solve them for a and b, for you and me. Let's go. So from equation 2, probably the easiest way to go, we can say firstly ab equals 6, and therefore b would be 6 over a, and we better substitute for that into equation 1 for b. Okay, so we get a squared minus 6 over a all squared equals 5, and we're going to solve that. Now what I've done there, ladies and gentlemen, is I've let that be 36 over a squared, and I'm multiplying both sides by a squared. So a to the 4th minus 36 equals 5a squared, and I'm going to try and solve that beastly looking thing. So a to the 4 minus 5a squared minus 36 equals 0. True enough. Oh, look at that. Very fancy. So we've got a squared minus 9 times a squared plus 4 equals 0. Well, I think we can deal with that, don't you? It'll be a pleasure. So therefore, we get a plus 3 times a minus 3 times, now, how did I do that? You know, don't you? That's a squared minus 4i squared, which gets us this. Yeah, isn't that beautiful? Now, there's something we've got to bear in mind here, ladies and gentlemen. Always keep the big picture in your mind and what has gone before. See that? A and B are reals, aren't they? Now, that's very important for what's going to happen next. So we can say that by the null factor rule, we can say that a would be plus or minus 3, or a would be plus or minus 2i. But a couldn't be plus or minus 2i because that. Yeah? So, yeah, that's true. So we're chucking that out. Therefore, a is plus 3, or a is minus 3. And now we can solve it for b, having got our two a solutions. And we know that b is 6 over a, therefore if a is plus 3, b would be 6 over 3, which would be 2. And if a was minus 3, b would be 6 over minus 3, which would be minus 2. It's pretty nifty, guys. Therefore z is 3 plus 2i, or minus 3 minus 2i. And that's the solution. All done in Cartesian form, and amazingly done, don't you think? So just keep that one in mind. It might come up in an exam or somewhere. Yes, we nailed it, and we had great fun, didn't we? Okay, thanks for being with me again, and we'll look forward to seeing you soon.